This video is a walkthrough of the Raspberry Pi lesson OK04. So what I have here is the code for the system timer. This code allows um, you to set a delay basically. So how it starts is like the other ones with a global function, get system timer base. What this does is just loads into R0 the address of the system timer base, which we can gain from looking at the specs of the Pi, and then goes back to where it was, just like in the previous lessons. The next thing it does is get timestamp. So get timestamp works is first of all we push our return register, then we branch to get this base timer. So now we have in R0 we have our base timer. Then we oh, then we this is a new command that we learn in this lesson, and it allows us to load um, 8 bytes, because these registers are 4 bytes. It allows us to load 8 bytes over 2 registers. So we're going to load over R0 and R1 whatever's in R0 offset by 4. So the reason this is done is because we can look at this little chart that we were given in the lesson, and this chart shows us that uh, this is what will be our base. This is our base register, and we can see that 4, because it's size 4 offset of that gives us the counter, which is the counter that's going to be constantly incrementing while the Pi is on. So we go back and we load that number, and I guess also you can see that the counter is 8 bytes, so we need to load it over 2 registers. So we load the counter over 2 registers, and then we pop back to where we were, as per how we've been doing it this whole time. So then we have the actual wait method. So this will wait the number of microseconds that is inputted into it before returning to where it was. So basically, we're setting our delay to R2 because we know that oh no, actually, this is creating an alias called delay, sorry, on R2 and then moving into R2 R0. So when this wait function is actually used, R0 will contain the length of the delay. So we're putting it into 2 so that we can use R0. So we once again push our return register. We branch to get our timestamp, which is the one we just did. So now we'll have the what the counter is. Then we'll create R3 will be start, and move R0, which is now our timestamp. Well, actually, R0, after calling the get timestamp, R0 will contain the highest 4 bits, which is all we're really going to need to do these delays. So we will, where was I? Right, we'll put our start into R0, and then we actually do our checks to see how long it will be. So get the timestamp will give us what it is now. Elapsed will be R1. Subtract elapsed into elapsed R0 from start. So essentially where we are now. So what we R0 will be what the counter has become, and we subtract that from we subtract what we started with from that, and that will be how much microseconds has passed. Then we compare that number, how many microseconds have passed since the last check, to the delay, and if it's less than, so if we haven't reached the time that we want the delay that we want yet, we just loop back and we keep going, and then Once we do, this will succeed. We can alias delay and start and pop a program counter to return. So this will wait a certain amount of time before doing it. And so in order to use this to do our flashing, we have our OK04 main method, which is identical to our OK3 main method. Same stuff. We branch to the main. We set our stack pointer. We get our GPIO functions, all of that. Except now we we load into R0 whenever we want a delay now, we load it. So here's where the original delay was. This is the set to 0 to turn it on, and then this is the set to 1 to turn the LED off. So in between that, we want our delay. So we set R0 to this number. This is just how many microseconds. So this will cause it to flash. You do the math. 1,000 microseconds will cause it to flash 5 times per second. And then we call our wait method with now R0, which will be our input, into the wait method of this. And then it will go off to system timer. It will perform the delay, come back, set the pin to off, and perform the same delay. And then it will go back to looping. So that's how we can use the timer in order to set a delay to flash the LED.